In this video, we will talk about copying arrays. So let's assume that we declare an array here called numbers, and it has the length 10. All right, so this is our array. Numbers has new and 10, so that's a length 10. Then let's say later on we decide, you know what, I'm not going to use all of the 10 elements, and I would like to make it 5 elements instead. Now, the question here, can you go and resize numbers such that it becomes 5 instead of 10? And the answer is no. If you remember, I repeated this a couple of times. The length of an array is final. You cannot change that. All right, so you once declare numbers to be an array of integers of length 10, it has to be like this forever. That's it, done. All right, now how to fix this? Like if I go and say numbers is equal to new int 5, in my way, or I'm hoping that I'm going to resize it to be 5. Is that really going to resize it to 5? And the answer is no. So if we want to visualize what is happening here, when we enter these lines, the first thing is that when you enter int square brackets numbers is equal to new int of 10, this actually creates the numbers reference variable. It has an address that is pointing to an array of 10 elements in the memory this way. Then you go ahead and say, no, you know what, numbers is equal to new int 5. What really happens is that a new integer array in the memory is created. It has 5 elements. Address of the numbers is going to be updated such that it points to this one. Now, garbage collector in its next cycle arrives and finds that this old 10 element array is not being used by any reference variable, so it deletes that one and collects it. So this is something that you just need to understand, that when you reassign an array like this here, this is not going to resize the old one and make it 10 elements or 5 elements instead. It's not going to work. What will really happen is that it's going to create a completely new array and points or make that reference variable points to it. Now this is very important to understand as you deal with arrays. So the other thing that we would like to talk about is that now, given this approach here, this means that if I go and create array 1, for example, here, all right, so I create, for some reason it's not working. All right, so I create array 1, I hard coded with these values 2, 4, 6, 8, 10. So that creates the 2, 4, 6, 8, 10 array in the memory, makes array 1 points to it. Then I go and say simply array 2 is equal to array 1. All right, now here, if you remember, array is an object. If you do something like this, this is not really copying. All right, so when we did this, I would assume that we are hoping that it's going to create a completely new array in the memory that has 2, 4, 6, 8, 10, and then it was hoping that this is going to point to it, and this is not what's going to happen. What's going to happen is that array 1 address is going to be assigned to array 2. So here address is going to be exactly the same like this one, which makes both of them pointing to the same object in the memory. All right, so that in this case is called shallow copying, the same as objects, and it's not going to work if we are really hoping to copy an object or an array. So let's say here, for example, array 1, I created array 1. It's going to be pointing to 2, 4, 6, 8, 10. And then I'm going to create array 2, right? And I'm saying array 2 is equal to array 1. Now let's try to do something here. Let's print array 1. All right, so what do you think is going to be printed? And before you answer this, remember array is an object. So what do you think is going to be printed? All right, and the answer should be the address. So here what is happening is that it's going to tell you what is the class that this is coming from, which is basically square bracket telling you it's an array. All right, it's of type double at this memory hash or location in the memory. All right, so this is array 1. Now let's go and try to print array 2. after doing array 2 is equal to array 1, you will notice that they have the same exact address hash here, which tells you that this is shallow copying. It's just copying the address and it's going to be pointing to the same object in the memory as this example shows. All right, so that is a proof, and that's good to know. Now the second problem that we need to deal with is how to actually print the contents of an array, right? Because now this is not very useful to me. So to do this, you will have to print the contents of an array manually, one by one. So here, for example, you could go and say for int I is equal to 0, I is less than array1.length I plus plus, and I want to system dot out dot print something like this, array1 sub I plus some kind of a space here just to list the elements in a nice way next to each other. That looks like an array, right? Now here I'm going to say, okay, system out the print line, just to go to a new line here. There we go. All right, that looks nice. And then I can repeat the same process here for array 2. All right, here is array 2, and there we go. It's going to be the same thing exactly, right? Now, the other thing that is going to convince you that this is really what happened, it's just a shallow copying, is that what if I go and say array 2 of 1 or sub 1 is equal to 14, and then I go back and try to print array 1 again. All right, so I'm going to comment this here. So remember the order: array 1 declared, loop to print it. This is what I'm going to get. Then I go say array 2 is equal to array 1, which is shallow copying. I convinced you of this. And then I say array 2 of 1 is equal to 40, which I'm changing array 2, second element in it. And then I go and print array 1 again, right? So if you do this, you will notice that it's going to change the second element, index 1, to 40 instead of 4. All right, so that's again another proof that this is shallow copying. It's not creating a new object. It's actually just accessing the same object in the memory. All right, so we're done with this. We now know that it's shallow copying. The next thing we want to do is how to properly copy an array. All right, to copy an array, you will need to copy the array in a way which is manually. You will need to copy element by element from array 1 to array 2. All right, so that is how you will copy. So this is how you would do it. If you look at it, you have integer first array 5, 10, 15, 20, 25. Then you go and create second array to be of the same length, and then you go loop from 0 to the length of this array minus 1, which is 5 for both of them, right? So it goes from 0 to 4. And then what you do is that you say the ith element of second array is equal to the ith element of first array. All right, so this way you are copying one by one. Okay, so here we could go back to the loop, to the code, sorry, and we could do this one by one. So I'm going to create array 3. All right, and I'm going to copy array 1 and array 3. Now, one thing I would like you to note here is that array 1 is 5 elements. Array 3 is declared to be 10 elements, which are going to be all zeros at the beginning. And then what I'm going to do is that I'm going to copy the first 5 elements of the whole array 1 into the first 5 elements of array 3. All right, so ideally they would be of the same length, something like this, 5, and then I'm going to print array 3 here. here, array 3, all right? So that would be something like that. Okay. Let's actually print something useful in front of this so we do not get confused. So let's put here array 1. And then let's put here array 1 again. And let's put here array 3. Alright. Oh, yeah, I didn't notice. I didn't focus on this one. So it should be printed before. So here, system.out.print. Now that inconvenience and problem that we are facing to print an array every time we want to print an array is going to be very useful for us to motivate the creating methods that actually deals with arrays, right? So we could create a method that takes care of that for us. All right, there we go. So array 1, 1, 3, after changing this to 40 here, and then I go and copy array 1 and array 3. Here we go. All right, now because we are copying array 1 and array 3, we cannot tell the difference from here. So what we can do is to go and say, okay, you know what? I'm going to print here array 1, right? The location first, and then some kind of something like this here. All right, so here, and just put array 3 here, compile. So this way we can see the addresses of both arrays, and they are different. All right, so this is array 1. It's printing this address. Array 3 is printing this completely different address, but array 3 is a copy of array 1, and that's why they have the same contents. All right, so that's how you properly copy an array into another. Now, one thing that you need to notice here is that what happens if array 3 was 10 elements instead of 5? Would it create a problem? And the answer is no. It's just going to populate whatever you had here. All right, and then I would just go and here say array 3.length, which it was set to array 2. And here is array, I messed up the array 1 and 2 and 3 because all of them of the same length, so it didn't really matter here. So there we go. So notice here array 3 was declared to be 10 elements. I copied the array 1 into array 3, which is 5 elements. So the first 5 elements of array 3 were populated, and then the rest, or the remaining 5, are going to be set to zeros by default. So that is something also to keep in mind, that once you define an array, it doesn't have to be completely defined. Completely filled. All right, it could be partially filled, and that's what is happening here in this case. A couple of things before we go is that if you go back to the original problem that we had here, in that specific statement which says, if I defined numbers to be 10 elements and then later on I find myself, no, I'm not going to use the 10 elements, I would like to reduce it to 5 elements. Can you do that? Now we know we cannot do that. But if we want, by creating that other or new object here, so let's say for example here, you had, let me delete this. I'd like to go to this example here and say, all right, let's say I had here 1, 2, 3, 4, 5, and I know I'm not going to use any of these. Then I go and want to resize numbers to be 5. So what you want to do is that you go and create the new array, copy this here, copy this here, copy, 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 and then make this point to that array. So here 1, 2, 3, 4, 5, and this way this would be collected, and now you have the new numbers having the first 5 elements of the old one into a completely new array. I'm going to show you how to do this explicitly as an exercise in the next video or the next lecture. All right, so before we go, there is something that we would like to talk about here, which is something called the enhanced for loop. Enhanced for loop is another for loop that is just a quick or shorthand way to display elements of an array without having to create a counter. All right, so here what you do is that this is the general format of it. All right, it's 4 again, but here instead of having a counter that is initialized to 0 and goes from 0 to the length and then increment, what really happens is that you create a data type counter here, which is similar to the contents of the array, and then what you do is that it goes in this way here, that this is the variable, right? And then you say that it's going to go over the whole array with the array name. All right, so if you have, for example, here an integer array of numbers is equal to 369, you have 3 elements of integers. So what you could do is that you could go and say for int val. All right, that's your variable, that's like your counter. All right, you can think of it as if it's a counter of type int, and that honestly it's not a counter, it's a variable actually. All right, a variable that is going to span over the contents of the array numbers. So what happens is that val starts as, and that's embedded, val is equal to 3, and then you print 3 here. Then val becomes 6, and then you print 6. Val becomes 9, and you print 9. All right, and you don't have to do this. The loop, the enhanced loop, is going to do it for you. All right, so if you want to see that, we could go here and check one of these loops that we use to print, and instead of doing something like this for loop 3, what we could do is to do val over array 3, and what I want to do is to print val. All right, compile. Oh, it's a double. All right, so in this case it should be double. All right, to match the contents of array 3, which val is going to loop over. And then what happens, that val keeps taking these values of array 3 and print it in this way. All right, so that is working, and it's going to print the contents. All right, now one thing here is that since you lost the counter, you don't have int I is equal to 0. 0 goes from array I goes from 0 to array 3 minus 1, or array 3 dot length minus 1. What is really happening here is that you cannot use this loop to assign values, right? So you cannot use it for assignment. You can just basically use it to read contents. So that is something to keep in mind.